There you go. See if this one works. Okay, so the very first step when you guys do this is to find your zeros. This is what you practiced yesterday in your homework. What makes this factor equal to 0? X equals what number? Positive 2, right? And again, when I say what makes it 0, what number do you plug in to make this true to be 0? So 2 minus 2 gets me 0. What you need, hun? Okay, so now we're going to plug this into synthetic division that goes on the outside. And if you remember from yesterday, for those that were here, you're just using these numbers all the way out in front. And it's pretty easy if you're good with just simple math. Okay, so I'm just going to plug those in on the top. 3, -4, 2, -1, 5, 3. Those go right on the top. Whoa.
It's okay,
It's all good. What did we do with this 3 in the beginning? We just dropped it down right there. When you're on the outside, you multiply. When you're on the inside, you add. So 2 times 3 gets me 6. -4 plus 6 gets me 2. 2 times 2 gets me 4. Add straight down.
6.
You get 6. Then you do 2 times 6 gets me 12. -1 plus 12 gets me 11. 2 times 11 gets me 22. 22 plus 5 gets me 27. What's 2 times 27?
54.
54. Now remember, this guy is your remainder. Whatever your last one is your remainder. And I have a remainder of 51. Okay. Now, we're just going to stop there for this one. We're not going to write it out like we did yesterday, where we would do like x to the 4th plus 2x cubed. Okay, we're just going to kind of warm up with just this, and then we're going to talk about this next piece. And this is where you need that calculator, because it does say, evaluate this polynomial when x is 2. So this is a very common question on the SAT. Okay, evaluate. Evaluate means just take that number, plug it in. Okay, find what the answer is. So all I'm going to do is I'm going to take that 2 and plug it into all of these x's. So that's what we're going to do with your fancy calculator. 3 parentheses something to the 5th. Just going to kind of set myself up here. All you're doing is you're taking that 2 and you're plugging it in wherever you see an x. And I'm going to put f of 2. So again, in red, I'm just putting a 2 into all of those. A very, very common question on the non-calculator portion of the SAT. Yes, you will be given, some of you, a 4-function calculator, but this is the exact. You see on the back, it says SAT testing. This is what you get. It doesn't have to the 5th power. It doesn't have to the 4th power. Okay, so I need you to get out your calculator and go ahead and give it a try. Practice it. 3 parentheses 2, close it up to the 5th. -4 parentheses 2 to the 4th. Give everyone a second to try it. You should just get a number. Did anyone get an answer? What'd you get? 51. Nice. Thank you to the 7 that tried it. Okay, so if you notice something between these two, it's the same problem, exactly the same question, but you'll notice between these two, the remainder and when you plugged it in ended up being the same. And that's kind of like the introduction to today, is that they're the same. And that's called the remainder theorem. They're the same. So again, when you do synthetic division and you get a remainder, or when you plug it in called direct substitution into your calculator, you don't need your calculator. Okay, they're going to be the same. And the reason why I teach you that is because on something like the SAT or a college entrance math part, whatever it may be, okay, you might not be able to use a calculator. This is a lot easier to do in your head than this is. Thinking 2 to the 5th, 2 times 2 times 2 times 2 times 2 times 3, minus 4 times 2 times 2. Like, to do that in your head versus this is a lot easier. And that's why we take the time to teach it to you. Because, again, if it asks you to evaluate, you could do synthetic division and get the answer a lot quicker, and it's a lot easier than just plugging it in if you don't have a calculator. Again, you can't, with this calculator, plug that in. It's just impossible. Okay? So that's why we teach this to you. So, again, the remainder theorem says that when you do your division using synthetic, whatever the remainder is going to be what the value is. So, this says, determine what the value is of -2. So, there's two ways to do that. You could directly take -2 and plug it in, or you can do synthetic division. Okay, we're going to do both for the first one, and then you get to choose from that point forward. Okay, so when it gives this is actually what the 0 is. So that is the 0. We're going to use -2, and we're going to do synthetic division first. Now, when you do synthetic division, always check, do you have all the powers? 4, 3, 1, 0. Am I missing anything? 2. Okay, if you're missing anything, you must put a 0 in it as a placeholder. So now let's go ahead and use those numbers. 1, -10, 0, 106, -105. Do the synthetic. Hopefully for those that were here can do this pretty quickly. See if you guys can do this synthetic division. I'll go through it for those that were not here. Okay, but if you were here, try to do it without me. So the very first step, if you were not here, is you bring down the first one. Whenever you're on the outside, you multiply. So 2 times 1 gets me -2. Add straight down. Whenever you're on the inside, you add. Pretty simple math. -10 minus 2 gets me -12. When you're on the outside, you multiply. -2 times -12 gets me a +24. When you're on the inside, you add. So I get 24. Outside, you multiply. -2 times a +24 gets me a
-48.
48. Thank you for those that were doing that. 106 minus 48.
58.
58. When you multiply, you get, -116. Add straight down, and you get -221. Now, the question is different from yesterday. Yesterday it says, what do you get when you divide? This question just says, what's the value of -2? Well, what we just learned about the remainder theorem, what is the value of -2? Anyone kind of make assumption based off of what we said earlier? Like if I were with my calculator right now, going to plug in -2, what would be the answer based off of what we learned? Yeah, -221. And that's your answer. Remember, yesterday we continued this. We wrote 1x cubed minus 12x squared. That was actual division. This is just finding the answer to whatever it's asking. This is more likely to show up on an SAT question than the ones we did yesterday. Okay. Now, some of you could have been like, hey, I don't like doing synthetic. It's not fun for me. You could have just taken -2 and plugged them in. And that's it. That's fine too. So we'll do that method next. So we're going to take the method now. So I'm going to use -3. You're not changing the sign, only when it's a factor. Yep.
Plug in the 2, and since it's missing the x, will it still come out the same?
It'll still come out the same. Yeah. You don't have to worry about the missing one. Yep. If you plug it in. Very good question. Cool. So now we're going to take this -3 and we're going to do direct substitution. So if you hear me say direct substitution, that literally just means take the number, plug it in. So we're going to do P of -3, and let's plug it into all of these with your fancy calculator. So again, you can see that there's two different ways that you can do this type of problem. Some people like it this way because they don't really care about doing stuff in their head. They rather just plug it in the calculator. And again, that's all you. I don't care. It doesn't bother me at all. Or you can do synthetic. It doesn't matter. Either way, whatever your method is, I'm cool with. You just got to make that decision later on. So you're going to take -3. You're not changing the sign like we did yesterday. Only when you're given a factor do you change the sign. So go ahead and take a moment and do that. And I'm going to go off to the side and do synthetic because I don't have a calculator with me. So I'm going to do synthetic, and maybe you can prove with me that it's the same thing. Nope, I'm good.
So Halloween is this Thursday, I guess?
Mhm.
Kind of random. But I was just wondering.
Nope, you're good. For those that plugged it in your calculator, did you get 60? Yeah. So again, you can see how fast I did that with my brain. I mean, yes, again, you could 100% plug it into your calculator, but then that kind of gives, leaves room for error. I think these numbers were easier to work with than to the fourth, to the third. If you don't use parentheses, then something might have went wrong. So your final answer is 60. So the value of -3 when you plug it in is 60. Whether you did this method or this method, either one is fine. Okay? Again, I did this on the side for me because I did not have a calculator on me. Well, I guess I did, but I didn't want to use it. Questions? You sure? Go ahead and flip it. Again, I like doing this kind of stuff with you just because you have not learned it before, and it's nice to finally teach you something that I know versus something that someone else has taught you, and then I'm reteaching it to you. That's why I like doing this kinds of stuff. All right, a couple more. So now there's something called the factor theorem. Remember, all these guys are factors of 24. And what it means to be a factor is just something can evenly divide into it. So a polynomial has a factor if and only if what is the remainder? When you plug it in, you get what? Remember from yesterday?
0.
0. Okay. If you do 8 divided by 4, you get 2. You don't get 2.5. You don't get 2.1. You just get 2. So it has no remainder. That's one of the biggest concepts. This is the factor theorem. We're going to use that to help us out. So given that x minus 2 is a factor here of this polynomial, we want to write it in factored form. So now we're going back to last week, and I told you that factoring would be one of those things that would be one step of a couple. And that's why I really tried to drill factoring into your brain last week. It's why we took a quiz on it. Okay, we did it for a whole chapter in chapter 4. So it says, given that it is a factor, we know for sure it does divide evenly, write the polynomial in factored form. Now, this is a different question. We want it to be like x minus 2, x plus 5, x plus 3, whatever it may be. Factored form is not x equals something. It looks like groups of parentheses. So let's go ahead and do synthetic. So what does x equal here? Because I'm given to it in factor form. What is the value of the 0? Positive 2. Okay, so let's go ahead and use that in our synthetic division. When we do synthetic division, 3, 2, 1, 0, we're good to go. We don't have anything that we missed. So I have 1, -3, -10, and positive 24. A couple people yesterday was walking around, not in here, but different classes, they forgot that 1. Remember that 1 still is part of the problem. All right, so we'll see how nice this is when you have synthetic. Some of you really struggled with factoring. Well, this might help you to get to there. So bring down the 1, 2 times 1 is 2. You see how fast it can go. So -3 plus 2 gets me -1. 2 times -1 gets me a positive 2. And then 10 minus 2 gets me a -8. I messed up. Where did I mess up? You're right. It is a negative 2. I was like, wait, I messed up somewhere. Thank you. And then I get negative 12. And then 2 times negative 12 gets me negative 24, which gets me 0. So it makes sense. Remember what the direction said. The direction said it is a factor. So if you don't get 0, you know you did something wrong. And that's how I knew when I was like, I did something wrong because it's not going to work out. That's why I said that earlier. Okay? It's really nice to be able to have that in the back of your head. So this is what we learned yesterday. I started at x cubed. So what is this guy going to be? X to the power of squared. And then minus 1x minus 12. Now, we can keep going. And this is what the point was of learning all this factoring. So when we go off to the side, we say, we got a factor, what multiplies to negative 12 and adds to negative 1. What 2 numbers would multiply to negative 12 but also add to negative 1? So when you do your chart, you have 1 and 12, that doesn't work. 2 and 6, that doesn't work.
3 and 4.
3 and 4, let's go play with the signs a little bit.
It'll be
Negative 4.
Good. Positive 3, negative 4. All right, we're almost done. We got one more step. Our final answer in factored form is, I'm going to keep putting arrows so you know where they're coming from. X plus 3, x minus 4. And let's talk about this for 1 second to make sure that you understand. My degree in the beginning was 3. I only had 2. Does anyone know what my other factor is from the beginning of this problem? Yeah. Except for I think it's x minus 2. X minus 2. This guy. And we're done. So synthetic, then factoring. And I told you that was going to come. We will not give you harder ones than ones with just 1. Okay, if you were in COSAT, maybe. Okay, but in here, we're just going to do A as 1 because I think this is enough steps for you. Okay. Now, again, if you were wondering where that x minus 2 came from, that's why the directions are super important. You got to make sure that's included. Okay. And a good way to check your answers, I have 1, 2, 3. My degree is 3. So that helped me. Let's do it again to practice. All right. So again, given that x minus 1 is a factor, so my remainder must be 0 then, I'm going to plug in 1 for my 0 and do synthetic. Am I missing any of these? 4, 3, 1, 0. Yeah, I'm missing my 2, unfortunately.
Oh, yeah.
So I have to make sure I do 1, negative 1, 0, negative 8, 8. Because I'm missing x squared. You got to put that placeholder in. All right, you guys are getting better at synthetic. The more you do it, the better you get. It's just a lot of multiplying and adding. Multiply, add, multiply, add. Bring down the 1. 1 times 1 is 1. Then I get 0. Then I multiply, I also get 0. When I add straight down, I get 0 again. Okay, lots of zeros. 1 times 0 is 0. Now when I subtract, I get negative 8. And then when I multiply, I get negative 8 and I get 0, which again, you should have known from the directions that you were going to get 0 because it says it is a factor. All right, be careful when we write this down. We're not going to go further from this one. We're just going to stop when we write this down. I started at x to the 4th, so this is going to be x to a power 3. Technically, this is plus 0x squared. I'm going to put x squared plus 0x and then minus 8. So I'm just going to write minus 8. You could write the zeros down, guys. I would not be mad at you. It just, when you do 0 times something, it goes away. So, but if you put zeros there, it's okay. What is my other factor? And we're going to be done. What else should I have right here?
1.
X minus 1. Very good. We're done. We could keep going further, but I don't want to do that to you guys today. Okay, we could take this and go further from what we learned last week. Okay. I just want you to do number 1, and I will give you your homework so that you can ask me questions. Again, I give you guys like 25 minutes for homework. So when you show up tomorrow, make sure your homework's done because it kills me. Because I give you time to ask me questions. I don't like giving you homework where you do it at home. I want you to ask me questions. Okay? Just call me over. remember, read the directions. It says, is it a factor? It's not really asking for a number. So this is a yes or no question. This is a yes or no, and then why.
So we don't have to add any number because
You're going to do some work, whether you plug it in, whether you plug in 4 or use synthetic with 4, but the real answer will be a yes or no question. Yeah.
but we have to add like a number, like you did, like add a 0 like in the middle.
Oh, that's something I want you to check. It goes 3, 2, 1, 0. I didn't skip anything, so you shouldn't. Again, whether you do synthetic division or you do direct substitution, either one's going to work. So you're going back to the first page here, and you're doing one of these, like this one. You can either do this method or this method, but remember, you have to get a 0 for it to be a factor. And that's the question it's asking. And there is a question like that in your test where it says, hey,